Now we continue the examples in the exercise 4.2. Here, example number 2, the problem number 11. Integral 0 to 1 under root of 1 minus x upon 1 plus x dx. Okay. Now, first we solve this integral. Here, integral 0 to 1 under root of 1 minus x upon 1 plus x dx. Now, how to find the integral of this? Okay, here it is in the type of the integrals of the special substitution. Okay, special substitution, under root of a square minus x square, integral of under root of a square minus x square. Okay, then we substitute x is equal to a sin theta, under root of x square plus a square. Then we substitute x is equal to a tan theta, and under root of x square minus a square we substitute x is equal to a sec theta, and it is a minus under root of a minus x a plus x, like that, a minus x a plus x. We substitute x is equal to a cos theta. Here the value of a, it is 1, so here we put x is equal to only cos theta. Okay, x is equal to cos theta. It is a special substitution, and such type of the substitution we also use in a derivative of inverse trigonometric function. Okay, here now this integral we can solve by using the special substitution here, and it is a definite integral. In the definite integral, when we use substitution, first change the limit and then solve the integral. Okay, here after substitution change the limit. Here put x is equal to cos theta. Here put x is equal to cos theta. Therefore dx is equal to minus sin theta, because derivative of cos theta, it is a minus sin theta. Then dx is equal to, you can write here, therefore dx is equal to minus sin theta d theta. It is a substitution. It is a definite integral. After substitution change the limits. When x is equal to 0, it is a value of x, then theta is equal to, it is substitution in the theta, then theta is equal to x is equal to 0. Here see carefully, then theta is equal to, okay, x is equal to cos theta, therefore theta is equal to cos inverse of x. That means theta is equal to cos inverse of 1. Okay, see carefully here, x is equal to cos theta, therefore theta is equal to cos inverse of x. When x is equal to 0, theta is equal to cos inverse of 0, and cos inverse of 0, it is a pi by 2. Okay, cos inverse of 0. And when x is equal to 1, when x is equal to 1, that is a cos inverse of 1, and then theta is equal to 0. See carefully this. Okay, and now our integral is integral 0 to 1, we can write pi by 2 to 0. Okay, and then it is under root of 1 minus cos theta upon 1 plus cos theta into minus sin theta d theta. Okay, it is dx is equal to minus sin theta d theta. Now we can use the formulas. Here this minus can take the outside the integral. It is a pi by 2 to 0 into under root of 1 minus sin theta, it is a 2 sin square theta by 2 upon 2 cos square theta by 2 into, it is a sin theta, again we use the formula for the sin theta, it is a 2 sin theta by 2 into cos theta by 2 d theta. Okay, see carefully, here we use 1 minus cos theta, 1 plus cos theta, and it is a sin theta. Trigonometric formula is of 1 minus cos theta, 1 plus cos theta, and sin theta. Now here it is a minus integral pi by 2 to pi by 2. Here 2 get cancelled. Sin square upon cos square. See carefully. It is a sin square upon cos square. here we can write it is a sin theta by 2 upon cos theta by 2. We can directly write it is a cot theta, but it is cos get cancelled here. 2 sin theta by 2 into cos theta by 2 d theta. Now it is a minus pi by 2 to 0 cos theta. This cos theta cancel. Sin theta it is a sin square theta. Therefore it is a 2 sin square theta by 2 d theta. See carefully. Minus pi by 2 to 0. 2 sin square theta by 2 cos theta by 2 get cancelled. It is 2. It is a sin theta into sin theta. Now we know that again 2 sin square theta by 2. It is a 2 sin square theta by 2 means 1 minus cos theta. And therefore minus integral pi by 2 to 0. It is 1 minus cos theta d theta. Okay, here 2 sin square theta by 2 means 1 minus cos theta. And then now integrate. It is a minus. Integral of 1 it is a theta, and integral of cos theta it is a sin theta. And limit pi by 2 to 0. Here it is a minus. It is a common for the both. So we can write here in the square bracket. First we take the upper limit. 0 minus sin 0 minus take the lower limit, that is a pi by 2 minus sin pi by 2. Okay, first we take the upper limit and then lower limit. Then it is a minus, it is a 0, it is 0, it is minus pi by 2, and here minus it is a plus, and sin pi by 2 it is 1. So the last answer, see carefully, it is a minus, so it is a plus pi by 2 minus 1. It is the last answer, pi by 2 minus 1, answer of this question. Okay, see carefully. Here it is a special substitution we put. Then change the limit 0 to 1. Here 0 to 1. Then the limit it is minus, it is pi by 2 to 0. It is pi by 2 to 0. And then we solve this integral. Okay, and after solving integral, we are taking the limit, upper limit minus lower limit. Okay. Now see carefully this example. Here in this example we observe that here it is a limit pi by 2 to 0. Okay. It is 0 to 1. Okay. When we take the limit, it is x belongs to a comma b. In the interval a is a less number and it is a b is a greater number. That means lower limit is less and upper limit is a greater than the lower limit. Here it is a 0 to 1, but in this here it is a pi by 2 and it is a 0. Okay. Lower limit is greater and upper limit is a less than. Okay. It is a wrong method, but here it is a minus. Okay. In this example there is a property of the definite integral. If the integral a to b, okay, f of x dx, then this can be written, it is a minus integral b to a. When we change the upper limit and lower limit, change the sign, it is a minus. That means when we write minus pi by 2 to 0, it means 0 to pi by 2. Okay, here it is minus pi by 2 to 0. It is a lower limit and it is upper limit, but here lower limit is greater than and upper limit is small. Here 0 to pi by 2, it is the correct. Okay, here it is a property of definite integral. The properties of definite integral we learn in our next lecture. Okay, after the completion of the second example. Okay, we will learn the properties of definite integral, and this properties of definite integral we use this property. Okay, here lower limit लहान असणार आणि अप्पर लिमिट काय असणार, मोठा असणार. पण इथं काय दिसायले, लोअर लिमिट मोठं आहे आणि अप्पर लिमिट लहान. ओके, लोअर लिमिट कधीही लहानच असणार आणि अप्पर लिमिट मोठं असणार. पण हिअर इथं उलट आहे, पण इथं काय दिलेलं आहे, हे मायनस दिलेलं आहे. ओके, मायनसमुळं आपण जर प्रॉपर्टी यूज केली तर हे वर जाणार आणि हे खाली जाणार. जर तुम्ही इथंच ती प्रॉपर्टी यूज करून सॉल्व्ह केलं तरी चालते, आन्सर हेच येणार. ओके, मायनस कट होईल, हे इकडून येईल आणि हे इकडून येईल. ओके, कॅल्क्युलेशन सेम. ओके, आन्सर सेम येईल. इथंच जर तुम्ही ही प्रॉपर्टी यूज केली तर. ओके, आणि प्रॉपर्टी यूज न करता डायरेक्ट सॉल्व्ह करा, कॅल्क्युलेशन सेम येते, कारण बाहेर मायनस आहे. ओके, फक्त लक्षात राहू द्या, लोअर लिमिट लहान असते आणि अप्पर लिमिट मोठं असते. ओके, पण इथं लोअर लिमिट या प्रॉब्लेमसाठी लोअर लिमिट मोठं आले आणि अप्पर लिमिट लहान, पण हे चुकीचं नाही कारण इकडे मायनस आहे. ओके, इंटरचेंज करता येते. ओके, प्रॉब्लेम चुकीचा नाही, काही नाही. ओके, केअरफुली पहा. याच्यानंतर पाहू आपण नेक्स्ट एक्झाम्पल. ओके, ह्या प्रॉपर्टीज आपल्याला आता याच्यानंतरच्या नेक्स्ट लेक्चरमध्ये घ्यायच्याच आहेत. प्रॉपर्टीज ऑफ द डेफिनाइट इंटिग्रल. देर आर 8 प्रॉपर्टीज. ओके, वी सी इन अ नेक्स्ट लेक्चर. Now, next example, example number 12. Integral 0 to pi sin cube x into 1 plus 2 cos x into 1 plus cos x square dx. Now, here integral is equal to 0 to pi sin cube x into 1 plus 2 cos x into 1 plus cos x whole square dx. See carefully this. Okay, here in the multiple of dx there are 3 terms: sin cube x, 1 plus 2 cos x and 1 plus cos x whole square. Okay, here we use the substitution. Okay, but the derivative of sin x is equal to cos x is not in the multiple of dx, and here derivative of cos x, it is a minus sin x, that is the derivative of cos x in terms of the sin x, is also not in the multiple of dx, but the derivative of cos x we can write it is a sin cube x. Sin cube x can also write in the form of the sin square x into sin x. That means the derivative of cos x in the multiple of dx. Okay, here integral 0 to pi sin square x into 1 plus 2 cos x into 1 plus cos x square into sin x dx. Okay, here sin cube x, it is a sin square x into sin x. Now put cos x is equal to t, but it is a sin square. Sin square can reduce in the form of the cos. 0 to pi, it is a 1 minus cos square. 1 minus cos square. 1 plus 2 cos x into 1 plus cos x square into sin x dx. And now put cos x is equal to t. Here put cos x is equal to t, and therefore we can write dx is equal to minus sin x dt. Okay, after substitution change the limit. When x is equal to 0, see carefully, when x is equal to 0 cos x is equal to, x is equal to 0, it is a cos 0 is equal to t, and then t is equal to 1, that is a cos 0. When x is equal to 0, here 0, cos 0 it is 1 is equal to t. When x is equal to 0, t is equal to 1. And when x is equal to pi, when x is equal to pi, it is a cos pi, and cos pi it is a minus 1. T is equal to minus 1. Now 0 to pi, new limit it is a 1 to minus 1, and then integral is minus 1 to, sorry, it is 0, 1 to minus 1, 1 to minus 1. Again here lower limit is a greater and upper limit is a less than, it is a negative. Okay, here it is minus sin theta d theta. Using the property, we can write minus 1 to 1, okay, or directly calculate, answer is same. Now here 1 minus t square into 1 plus 2t into 1 plus t whole square into, here it is minus 1 minute, it is cos x, derivative of cos x, it is a sin x, dx is equal to minus dt. Okay, now here it is a minus dt. Okay, now this minus can be written in the outside the integral 1 to minus 1. Now multiply these two. Here 1 into 1, 1 into 2, 2t, it is a 2t, t minus t into 1, minus t square, and here minus t into 2t, it is a minus 2t cube, and into 1 plus 2t plus t square in dt. Okay, see carefully this. Okay. Multiplication of these two brackets, and it is a whole square, 1 plus 2t plus t square. Now we multiply these two brackets. Therefore integral is equal to minus 1 to minus 1. Okay, here take the multiplication carefully. We can multiply by 1 to this term, therefore it is 1 plus 2t plus t square. Multiply by 1 to 1 plus 2t plus t square. Now multiply by 2t to this term, therefore it is plus 2t plus 4t square. 2t into 2t, it is a 4t square, and it is a 2t and t square, it is a 2t cube plus 2t cube. Okay, here we multiply by 1 and multiply by 2t to this bracket. Now multiply by minus t square to this bracket, then it is a minus t square minus 2t cube minus t square and minus 2t. Now minus 2t minus t square, and it is a plus t square, it is a minus t to the power 4. Now multiply by minus 2t cube to this term, it is minus 2t cube minus 4t to the power 4, and last minus 2t to the power 5 dt. Okay. Then it is a minus 1 to minus 1. Now see carefully, first take the constant, it is a 1. Now t, here 2t, and it is a 2t plus 4t. Okay. Now square, it is a t square plus 4 square, it is a 5t square. T square and 4t square, it is a 5t square. 5t square minus t square, again it is a 4t square. Okay, now it is a plus 4t square. Okay, now cube, here it is a 2t cube and minus 2t cube get cancelled. Here it is a minus 2t cube, minus 2t cube. Now t to the power 4, t to the power 4 it is, t to the power 4 it is t to the power 4, minus 5t to the power 4, and last t to the power 5 it is minus 2 into t to the power 5 dt. It is a calculation of this. Okay, now find the integral. Then it is minus as it is, integral of 1, it is a t plus 4 t square by 2, integral of t plus 4 t cube by 3 minus 2 t to the power 4 by 4 minus 5 t to the power 5 by 5, and minus 2 into t to the power 6 by 6, and limit 1 to minus 1. Calculate this. Minus here it is a t plus it is 4 by 2, that means 2t square plus it is a 4t cube upon 3 minus it is a 2 and 4, it is a 1 by 2, therefore it is a t to the power 4 upon 2 minus 5 get cancelled, it is a t to the power 5 and minus 2 and 6, therefore it is a 1 by 3, therefore t to the power 6 upon 3 and limit 1 to minus 1. Okay, now we put the limit first, upper limit, that is the minus 1, t replaced by the minus 1 and then minus t replaced by 1. Now first we put the upper limit, see carefully, t is equal to upper limit is a minus 1, that means we put the value of t in all t, it is a minus 1, therefore it is a minus 1 plus it is a t square, see carefully, minus 1 square it is a plus 1, therefore it is a 2. Here t cube, that is minus 1 cube, it is a minus, therefore here minus 4 by 3. Okay, here t to the power 4, that means minus 1 to the power 4, it is a plus 1, therefore it is a minus 1 by 2. Okay, it is a plus 1, therefore minus as it is. Now here t to the power 5, that is minus 1 to the power 5, it is a minus 1 and this minus, therefore it is a plus 1. And here t to the power 6, that is minus 1 to the power 6, it is a minus 1, sorry, it is a plus 1. T to the power 6, power even, minus 1 to the power 6, it is a 1 by 3, that means minus as it is. Okay, here it is upper limit. Now we put the lower limit, minus. Lower limit it is a 1, we put the value of t, it is 1, that is 1 plus 2 plus 4 by 3 minus 1 by 2 minus 1 and minus 1 by 3. Okay, here we put t is equal to 1 in this. Okay, it is a lower limit and it is upper limit. Now only the calculation of these all terms. Then it is minus as it is. See carefully, it is a minus 1 and it is a plus 1 get cancelled. Only here 2. See carefully, it is a 2. It is a minus 4 by 3 and minus 1 by 3. It is minus 5 by 3. It is a minus 1 by 2. Okay, here see carefully, minus 1 plus 2, it is a plus 1 and this plus 1, it is a 2, minus 4 by 3 and it is a minus 1 by 3, it is minus 5 by 3 and it is 1 by 2 as it is. Okay, it is the first bracket, that is the values of the upper limit, minus. Again here 1 plus 2, it is a 3 and again minus 1, therefore it is a 2. Okay, and here 4 by 3 and it is a minus 1 by 3, it is 3 by 3, therefore it is a plus 1, it is a 3, see carefully, 4 by 3 and it is a minus 1 by 3, therefore 4 minus 1, it is a 3, 3 by 3 it is 1 and remaining it is minus 1 by 2. Okay, now we calculate all, then it is minus, see carefully, here it is a 2 and these 2 get cancelled, 2 and it is minus 2 cancel, again calculate, it is a 2 and here it is a minus 10 and 3, it is a minus 13. Okay, 1 minute, we take separately. Okay, here it is a 2 minus 5 by 3 minus 1 by 2 minus 2 minus 1 and it is a plus 1 by 2. Okay, separate. Now it is 1 by 2 get cancel. Okay, 2 get cancel. Here only remaining minus 5 by 3 and minus 1. Therefore it is a minus 5 by 3 minus 1. It is a minus 8 by 3. Therefore the last answer it is 8 by 3. It is minus 8 by 3 and it is minus. Therefore the last answer it is a minus 8 by 3. Okay, check all the calculation carefully. Okay, here see carefully this example. Now we see the next example. Next, example number 13. Integral 0 to pi by 2 sin 2x into tan inverse of sin x dx. Okay. Now here it is a sin 2x into tan inverse of sin x. It is a tan inverse of sin x. To find the integral of the composite function, we use the substitution. Okay. Here tan inverse of sin x, that means here we put the sin x, but the derivative of sin x is not in the multiple of dx. Okay. Here, but here given it is a sin 2x, and sin 2x means 2 sin x into cos x, and derivative of sin x, it is a cos x. That means when we use the formula for the sin 2x, there is a derivative of the sin x in the multiple of cos x. Okay. Now see carefully this. Here integral 0 to pi by 2 sin 2x into tan inverse of sin x. Now here integral 0 to pi by 2 2 sin x into cos x into tan inverse of sin x dx, and now we put sin x is equal to t, and it is a derivative of sin x, it is a cos x. Put sin x is equal to t, therefore cos x dx is equal to dt. It is a definite integral, so change the limit. When x is equal to 0, t is also 0, because x is equal to 0, then it is a 0, sin 0, and sin 0 is 0, therefore t is equal to 0. And when x is equal to pi by 2, t is equal to 1. When x is equal to pi by 2, that means it is a sin pi by 2, and sin pi by 2 it is 1, therefore the value of t is 1 when x is equal to pi by 2. Now our limit, new limit, it is a 0 to 1. Then integral is equal to 0 to 1, see carefully, it is a 2t, it is cos x dx, it is dt, and into tan inverse of t dt here. And now it is a t into tan inverse t. It is a product of the two functions, integration by parts. But integration by parts, we take the inverse function as a first and algebraic function as a second by the rule LIATE. First we take the logarithmic function, then inverse, then algebraic, trigonometric, and exponential. Okay, here it is a inverse and it is an algebraic function. So in the integration by parts, tan inverse take first and t take a second function, and 2 it is a constant, take the outside. 2 into integral of 0 to 1 tan inverse t into t dt. And now here we use the integration by parts. See carefully. Here it is a 2 into integration by parts. It is a tan inverse t into integration of t dt minus integration of derivative of tan inverse into integral of t dt and dt. Okay, here the limit it is a 0 to 1, we can write the after the completion of the integration. Now here 2 into here tan inverse t into integral of, it is a t square by 2 integration of t minus integral of derivative of tan inverse, it is a 1 upon 1 plus t square into t square upon 2 dt. Now this term we can write here 2 into, it is t square by 2 into tan inverse t square by 2 into tan inverse, it is the first term, and in the second we can take 1 by 2 common integral of t square upon 1 plus t square dt. Okay. Then these two and these two get cancelled. Therefore, this is t square by 2 tan inverse t minus this 1 by 2, 2 get cancelled. These two and these two get cancelled. Okay, it is to cancel. Here, these two get cancelled. Here it is a t square. Now, integral of, again here, t square upon 1 plus t square. Here the degree of polynomial in numerator and degree of polynomial in denominator is the same. So, adjust denominator as it is in the numerator. Therefore, we can write 1 plus t square. But in the numerator there is only t square. Therefore, they cancel this minus 1. 1 plus t square dt. Okay. And now, t square into tan inverse t minus integral of 1 plus t square upon 1 plus t square minus 1 upon 1 plus t square dt. And now last, it is a t square tan inverse of t, see carefully, minus 1 plus t square get cancelled. Here it is a 1 and integral of 1 it is a t. This minus plus and integral of 1 upon 1 plus t square, it is a tan inverse t. It is an integral, but it is a definite integral. So put the limit, it is a 0 to 1. Okay. And now first put upper limit and then lower limit. Okay. Therefore, upper limit, it is a 1 square into tan inverse of 1 minus 1 plus tan inverse of 1 minus lower limit, it is a 0 into tan inverse of 0 minus 0 and plus tan inverse of 0. Okay. Here when we put the lower limit, the all terms are becomes the 0. It is 0, 0 and 0. Okay. Then it is 1 into pi by 4. 1 into pi by 4 minus 1 and plus pi by 4. And these all terms are the 0. Okay. And then the last answer, pi by 4 plus pi by 4. It is pi by 2 and minus 1. Okay. See carefully this. Okay. Now, the next example. Then example number 14, integral 1 by root 2 to 1 e raised to cos inverse x into sin inverse x upon under root of 1 minus x square dx. Okay. Now here example number, it is 14. Take integral is equal to 1 by root 2 to 1 e raised to cos inverse x into sin inverse x upon under root 1 minus x square dx. See carefully this. Okay. Here it is a 1 upon under root 1 minus x square dx. It is a derivative of sin inverse x, and this can be written in the derivative in the form of the cos inverse x. Derivative of cos inverse x, it is a minus 1 upon under root 1 minus x square. But here we put sin inverse or cos inverse. Okay. Here we put cos inverse x is equal to t, because cos inverse in the composite form e to the power cos inverse x. Here we put cos inverse x is equal to t. Okay, when we put cos inverse x is equal to t, then it is derivative of cos inverse, it is a minus 1 upon under root 1 minus x square. Okay, therefore 1 upon, that is a dx upon under root 1 minus x square is equal to minus dt. But here it is a sine inverse. Okay, first sine inverse can write in terms of the cos inverse. Now here we use the property of the inverse trigonometric function, e to the power cos inverse x as it is, into, here we know that sine inverse x plus cos inverse x is equal to pi by 2. What is sine inverse x plus cos inverse x is equal to pi by 2. Therefore sine inverse x is equal to pi by 2 minus cos inverse x. It is pi by 2 minus cos inverse x and whole to the upon under root 1 minus x square dx. And now here put cos inverse x is equal to t. Put cos inverse x is equal to t. Therefore dx upon under root 1 minus x square is equal to minus dt. Okay, derivative of cos inverse x, it is minus 1 upon under root 1 minus x square, and here dt by dx, dx here and minus in the RHS. Okay, now it is a definite integral, so change limit when x is equal to 1 by root 2, t is equal to cos inverse of 1 by root 2, therefore t is equal to pi by 4. And when x is equal to 1, t is equal to 0. Okay. Cos inverse of 0, sorry, cos inverse of 1, it is a 0. Cos inverse of 1, that is a cos 0, the value of cos 0, it is 1. Therefore cos inverse of 1, it is 0. Now therefore our integral is here 1 by root 2 to 1, it is pi by 2 to 0. It is pi by 4, yes, to 0. And here e to the power t, e to the power t into pi by 2 minus t, pi by 2 minus t, and it is a minus dt. See carefully this, e to the power t, pi by 2 minus t, and dx upon under root, dx upon under root, it is minus dt. We take minus outside, it is minus pi by 4 to 0 multiply by e to the power t, therefore it is pi by 2 into e to the power t, and minus e to the power t into t dt. Now separate the integrals, both the integrals separately. Here minus, okay, yeah, we can write in this, here it is a minus, and these are the two terms. Right, only the separate the integrals. Okay, separate these two integrals here, these two terms we separate, it is minus, so first term it is a minus and second term it is a plus because this minus. Okay, and separate the integral to both the terms. Okay, therefore here minus pi by 2 into integral pi by 4 to 0 e raised to t dt. Okay, and here plus this minus and this minus, it is a plus, into integral of pi by 4 to 0, and it is e to the power t into t dt. Okay, now see carefully, here it is a standard integral, but here we use the integration by parts, and in the integration by parts, e to the power t, it is exponential and it is algebraic. Okay, algebraic it is a first function and exponential it is a second. Okay, here e to the power t into t, we can write t into e to the power t. Okay, now we solve the integrals, it is a minus pi by 2 into e to the power t, integral of e to the power t, it is e to the power t, and limit it is a pi by 4 to 0, and now plus, first we find the integral and then substitute, put the limits. Here t into integral of t, u into v, minus integral of derivative of t into integral of e raised to t dt and dt. Okay, and now here minus pi by 2 into e to the power 0 minus e to the power pi by 4. Okay, here we put upper limit minus lower limit, and now it is an integral. We can solve this. It is t into e to the power t minus integral of, it is 1 into e to the power t dt. Here it is minus pi by 2, e to the power 0 it is 1, and it is e to the power pi by 4. Okay, plus here see carefully, t into e to the power t minus it is e to the power t, and limit here pi by 4 to 0. Now here upper limit minus lower limit. First term as it is minus pi by 2, okay, into 1 minus e to the power pi by 4, plus here upper limit minus lower limit, 0 into e to the power 0 minus e to the power 0, minus pi by 4 into e to the power pi by 4 minus e to the power pi by 4. Okay, here upper limit minus lower limit, pi by 4, pi by 4, pi by 4 here. Okay, now we calculate only. Here it is a minus pi by 2, see carefully, minus pi by 2 plus pi by 2 into e to the power pi by 4. Here minus, and it is minus plus. Okay, now here plus, it is 0 but it is minus 1. Okay, so we can write here it is a minus 1. Okay, this bracket, and here it is minus, see carefully, minus pi by 4 into e to the power pi by 4, and this minus minus plus e to the power pi by 4. Okay, here, and now we take common e to the power pi by 4, so it is e to the power pi by 4, e to the power pi by 4, and it is e to the power pi by 4. Therefore e to the power pi by 4, then we get it is pi by 2, then minus pi by 4, and then plus 1. Okay, e to the power pi by 4, e to the power pi by 4, e to the power pi by 4, it is pi by 2 minus pi by 4, and it is plus 1, and here remaining minus pi by 2 and minus 1. Okay, and now last answer, see carefully, it is e to the power pi by 4 into, it is pi by 2 minus pi by 4, it is pi by 4 plus 1, and here take the minus common, pi by 2 plus 1. It is a last answer, see carefully. Okay, here only separate integral, it is a direct integration, that is standard function, and it is using u into v. See carefully, it is a last answer. Now you see the last example in the example 2. Example number 15. Integral 2 to 3 cos of log x upon x dx. Okay. Here it is a simple example. Put log x is equal to t. Cos of log x upon x dx. Put log x is equal to t. Therefore, one by x dx is equal to dt. Now change the limit. When x is equal to 2, t is equal to log 2, and when x is equal to 3, t is equal to log 3. Okay. Now integral log 2 to log 3 cos t dt, cos t, and it is a dt. And now integral of cos t, it is a sin t, and limit log 2 to log 3. See carefully this. Okay. Here cos of log x, put log x is equal to t, therefore 1 by x dx is equal to dt. And limit, put log x is equal to t, when x is equal to 2 it is log 2, when x is equal to 3 it is log 3. It is cos t dt, and integral of cos t, it is a sin t, integral of cos t, standard integral. And now here put the limit, sin of log 3 minus sin of log 2. Here it is the last answer, sin of log 3 minus sin of log 2, upper limit minus lower limit. It is the answer. See carefully this.